Welcome everyone to the Elite of our Chemistry Learning Club, and today we are going to talk about the reaction flowchart, a simple flowchart that I've made to allow students to recognize whether a reaction is undergoing SN1, E1, SN2 or E2 reaction. Before I proceed, there are some things that I just want to make it clear. Maybe someone might not know the meaning of SN1. So when we are talking about SN1, SN1 is just substitution nucleophilic unimolecular, and SN2 is just substitution nucleophilic bimolecular. With respect to the E1 and E2, E1 is also elimination unimolecular and E2 is elimination bimolecular. So considering these flowcharts, it's either you're having a strong or weak nucleophile or a base. Now let's try and look at some characteristics of these SN1 or the characteristics of these reactions. And we take SN1 for instance, which is the substitution nucleophilic unimolecular. It's having some key features that you're supposed to know. It is made up of two-step mechanism. Two-step mechanism in a way that carbocation is always formed for SN1 reaction. As in, the leaving group will leave and a carbocation will be formed, which is a rate determining step in summary. Then the nucleophile will then attack the carbocation for the reaction to form. So I'll be talking about some of the characteristics of the SN2 as well. But in all, for SN1, carbocation rearrangement is possible or occurs usually, and also resmerization, which is inversion of the stereochemistry. It's either there's an inversion or there's a retention of the stereochemistry of the compound. For SN2, if you are considering SN2, which is a substitution nucleophilic bimolecular, we are going to realize that there is some key features. There is no carbocation formed. The reaction is just a one-step reaction. Concerted mechanism is only one. Whilst the leaving group is leaving, we are having the nucleophile also attacking it. Now, with respect to the E1, which is the elimination unimolecular, it's also made up of two steps. The leaving group leaves and the proton is removed. So for elimination reaction, I'm going to realize that a double bond is always formed. So that's the difference between SN1 and E1. A double bond is always formed because hydrogen or proton is removed for a double bond to be formed. Now, with E2, so this one too, carbocation is also possible, or carbocation occurs and it produces a more substituted alkene, which in this case we are referring to it as the Zaitsev rule or the Zaitsev product. For Zaitsev product, more substituted alkene is what produced. Then with the E2, that's when we are going to have a one step. It's also a concerted mechanism where it's having only one step. Whilst the leaving group is leaving, the proton is also leaving along with it in order for a double bond to be formed. So let's give a quick summary of all what we have done. For reaction of SN1, it's having two steps, and also the rate depends on the substrate. For SN1, the rate depends on the substrate, and there's rearrangement, yes. For SN2, the step is only one, and the rate depends on the substrate and the nucleophile, and there is no rearrangement. For E1, there are two steps, and the rate depends on only the substrate. Whenever you are having two steps, it depends only on the substrate, and the rearrangement is yes, rearrangement occurs. And for E2, because the step is also one, it depends on the substrate and the base, not the substrate and the nucleophile, but the substrate and the base. And no rearrangement occurs here for E2. So now let's try and move on to what we are seeing here, our flow chart. I'm zooming in so that everyone can see. So you can have your strong or your weak nucleophile or base. So if your nucleophile or your base is strong, for instance, OH, which is our hydroxide or our cyanide or any halide ion, all these things are strong nucleophile or bases. So the moment they are strong, then we are moving on to is either whether it's SN2 or E2. So if it is SN2 or E2, we are going to base on the type of substrate. Now, if the substrate is primary, then yeah, it's either you are going to get E1. If the substrate is a primary substrate, you end up checking out for whether it's a nucleophile or a bulky base. If you are saying a primary, secondary, or tertiary substrate, let me move on to my next presentation so that you get to know what a primary substrate is. Ethanol is a primary substrate. As you are seeing here, ethanol is a primary substrate because you're having the OH bonded to only one carbon. Isopropanol is a secondary substrate because we are having our OH bonded to a carbon that's also bonded to two other atoms or two other carbons. Then our tertiary substrates, this one is a tert butanol. This one is our tertiary substrate. You could see very clearly that the OH is bonded to a carbon that's also bonded to other three carbons. So this is the difference between a primary substrate, secondary substrate, and a tertiary substrate. So now let's move on back to what we were doing. Now, if the substrate is primary, then you are going to consider whether the nucleophile is strong or the base is bulky. If the nucleophile is strong, it is undergoing SN2 reaction. But if the base is bulky due to steric hindrances, then we are going to undergo A2 reaction. Moving on to the secondary substrate, you see that you're having a nucleophile or a base. If the base is stronger than a nucleophile, then you are going to have A2 reaction occurring. So your major pathway is A2. But if your nucleophile is very strong, then you are going to have SN2 major pathway. Moving on to the tertiary, you are going to consider that it's having a stronger base or a stronger nucleophile. But here, if you're having a nucleophile, no reaction will occur due to the steric hindrance. Remember, tertiary substrate is a very large molecule. As you can see here, this one is a tertiary substrate. So it cannot undergo SN reaction, but the only thing it can undergo is what? Elimination reaction in order to create a double bond. So here, it's only the base that works out to make the reaction possible. If you're having a nucleophile, due to steric hindrances, the reaction will not occur. So it's only a base that could lead you to your A2 reaction. Now let's move on to our SN1. If our nucleophile or our base is weak, especially water, alcohols, ammonia, hydrogen fluoride, let's say this one is also an acid, more like ethanoic acid. If you are considering the substrate type, if the substrate type is primary, then remember that no reaction will occur. The reason why no reaction will occur is due to the steric hindrances. So no reaction will occur for the substrate type because we are going to have a carbocation or a carbocation will be formed. But despite the carbocation will be formed, this carbocation that will be formed will be very unstable. And because of its instability, the reaction is likely not to be possible because you are going to reach a transition stage where the reaction will go back to the reactant side without going back to the product side. So the reaction is not going to occur. Now let's consider the secondary and the tertiary. For the secondary and the tertiary, only the thing that you are supposed to consider here is that do you have heat or you don't have heat. If you're having a heat, as you can see here, then this means E1 will occur. But if there is no heat, then you are going to have SN1 occurring. I'll give you guys the vivid explanation why if there's a heat, we are going to E1. If there is no heat, we are going to SN1. Before that, let's just focus on this flowchart and understand it very well because it's very interesting for you to understand this thing and predict reactions as well. Whether the reaction is going to be SN1, SN2, E1, E2. So now let's move on to some of the animations. This one is a typical animation that I had from one of my websites. Yes, depicting SN2. Remember, SN2 is just a one-step mechanism. Whilst you are having your nucleophile attacking the carbon, you are having your leaving group also leaving. And here, halide ions are one of the best leaving groups. So you could see that chlorine is leaving. And as it is leaving, you are having inversion of what? Stereochemistry. Your stereochemistry changes. Here we are having our hydrogen. You can see that this time we are having our hydrogen pointing at the back. But after bromine has attacked it, we are having our hydrogen pointing somewhere else. This one is going to change the stereochemistry. But for this particular compound, it's not a chiral it's not a chiral compound because this carbon is bonded to three similar groups, which is three similar hydrogens. So let's look at this animation to understand what we mean by SN2. So this one is SN2. So you see, whilst the leaving group is leaving, you are going to have your nucleophile also attacking. So we are going to have a transition stage between these two. There's a transition stage that is being formed, and this transition stage is very unstable. So this thing happens before the leaving group leaves. Now, considering E1, this one is a typical example of E1 reaction. So you can see that this E1, here there's a carbocation. If you could study it very well, there's a plus sign on this carbon in the middle. So the moment you are going to have your bromine leaving, there's going to be a plus sign, and this plus sign indicates carbocation or carbocation. So now, after this carbocation is being formed, the compound is going to rearrange, and water, you see, in the presence of water, water is come to remove extra hydrogen from there to give us a double bond, and this reaction is occurring in an acidic medium. So this is the general reaction flowchart that I wanted everyone to know. As time goes on, I'll be putting in more effort to explain some of the reactions very well to you, including the inversion of stereochemistry after a particular reaction has been formed. So thank you all for having your time to watch my video. Goodbye.